Hi everyone. Let's take a look at the following example. Determine the equations of two lines that pass through the point -1, -3 and are tangent to the graph of y equal to x squared plus 1. Step number 1. Draw a diagram. If you think about this carefully, the first question is, how do we know there are two tangent lines and not one? And more importantly, are we going to get nice numbers? Is this going to be an approximation? Am I going to get exact numbers? Let's find out. So if I set up a scale going up by 5, let's say down by 3, let's go right by 3, left by 3, this should be enough in terms of graphing what is given to us. So for example, if I think about y equal to x squared plus 1 from grade 10 academic math, this basically opens up with a minimum at 0, 1. And again, if you follow the step pattern, you can go right by 1, up by 1, right by 1, up by 3, and so on. So 1, 2, 3, 4, 5, up by 3, roughly speaking, something like that. So let's label this function y equal to x squared plus 1. Now, if you think about the point, -1, -3, I go left by 1, I go down by 3, I labeled this as well. Now, again, how do we know there are two tangent lines? Here's the educated guess. So we don't know for sure the location yet. And by inspection, my educated guess is that it's going to be an approximation. We're not going to get these nice numbers just by the way I'm graphing this. And this is just my educated guess. I guess we'll find out in a moment. I would like to do this whole question with you in a live session as we speak. So if I draw one tangent, it appears to be something like that. If I draw a second tangent, it appears to be, roughly speaking, something like that. So again, I recognize it's not to scale, right? This is a little bit rough and ready, but I think it's good enough in terms of what we're trying to do. So if I erase with this, I guess I could connect them a little bit more so that you can see how eventually the graph connects. Again, it's not a perfect graph, but I just want to demonstrate to you. We can find the exact answer first and go back and update the graph. This first step is just to show you that there are two tangents that you're looking for. And we're going to find out the exact points in a moment. So I go back to the given and I start with y equal to x squared plus 1. My goal is to find the general slope. And to find the general slope, you have to find the derivative. So y prime, or dy by dx, this is going to be 2x, which is basically the general slope. Again, there's a distinction between the general slope and the specific slope. And right now, 2x is the formula or the equation that we can use to find the general slope. Now, the idea is you want to write down m equals to m, which means slope equals to slope. And this could be, you can think of m as slope, which could be specific slope or general slope. In this case, the left-hand side is definitely the general slope. Now, what about the right-hand side? Well, let's go back. If you pick one of these points, and I can call this point, let's say xy. Well, if I highlight these 2 points right here, I can definitely find the slope. And if you think about grade 9 math, to find the slope, you're looking at y2 minus y1 divided by x2 minus x1. So in this case, it's going to be y minus -3 divided by x minus -1. Now, the concern here is that we cannot solve for x because we have everything in terms of x and y right now. And the key is to express everything in terms of x. How do we do that? We're given y equal to x squared plus 1. So we're going to plug it in, which means 2x equals to x squared plus 1. -3 would be +3 divided by, again, x plus 1. And we can solve for x now. Again, just by inspection, I can already tell we're not going to get nice numbers. I'm doing a little bit of mental math as I'm looking at this. So first I'm going to cross multiply. I'm going to take 2x, and again, this is really 2x divided by 1, and I cross multiply, so this multiply like that. So 2x times x plus 1 equals to 1 times x squared plus 4. Now at this point, think about how to solve for x. If I expand the left-hand side, this is going to be 2x squared plus 2. On the right-hand side, this is going to be x squared plus 4. I bring everything to one side, and this is going to be 2x squared minus 1x squared. That's going to be x squared. Oops, let's write that down. Now I can already see I made a mechanical mistake here. This is how you know I'm doing it live with you. 2x times 1 is 2x, not 2. Here we go. So x squared plus 2x minus 4. Now at this point, you're going to think about how to solve for x. Naturally, you want to start with factoring. But remember, just because it's not factorable, it doesn't mean it's not solvable. So I'm not going to use factoring as my next step. Instead, I'm going to apply the quadratic formula. So again, if you think about the quadratic formula, something you did back in grade 10 academic math, that's going to be negative b plus or minus b squared minus 4ac divided by 2a. Now, just in case you forgot, and you're thinking, I forgot what are the values of a, b, and c, can we get a refresher? Of course. Again, one more time, a is going to be 1. And of course, b is going to be 2. Let's highlight everything for you. Nobody should be left behind. Sometimes these are the mechanical steps that are holding students back, and we want to make sure that we help you. We support you. You got this. So c is going to be negative 4. Okay. So now I go back to the formula, and I can say, or I can write down the following. I'm going to come back to here, I guess. Let's maximize the space. So x equals to negative b, which is negative 2, plus or minus the square root of b squared is going to be 2 squared minus 4 times a times c divided by 2a, which is basically 2 times 1. Now, at this point, you have to remember, your goal is to find the equation. So we will use the calculator. It is going to be approximation. And I'm going to write it right here for you. So take your calculator. I'm taking mine. Let's work it out. So in the first case, I take a negative 2 plus the square root of 4 plus 16. Divide that by 2. Now, in the display, I see the following number, 1.236067977. Likewise, in the second case, if I take negative 2 minus, again, 4 plus 16 underneath the square root, divide that by 2, I see approximately negative 3.2360679777. And at this point, follow your teacher's model. Whatever your teacher does in class, you might want to follow that as your best course of action. But what I am going to do is round this to 2 decimals. Now again, it really depends. Some teachers round this to 4 decimals, 1 decimal, and you just got to follow your own teacher. But again, I'm going to round to 2 decimals here. I can already imagine the final answer is going to be a little bit messy. I may not even express this in standard form for you. I might just leave it in y equal to mx plus b form. Now, I'm going to divide this into 2 different columns. Are you ready? We're more than halfway. Really important, you find the coordinate. You're not just finding the x value, but you're finding x and y. And all you have to do is this. Y equals to x squared plus 1. So you're going to plug in the first case, 1.24 back into the calculator, and I'm going to work it out with you. So again, if I take 1.24 squared plus 1, that's going to be 2.5376. Now, I am going to leave it as this just to maximize the accuracy, even though we rounded by 2 to 2 decimals. So at this point, y equals to mx plus b. And we need to find m first, so maybe I should take a step back. To find m, all you do is this. M, the specific slope, equals to y prime of 1.24. So again, I'm just going to write this down on the side for you. Remember, y prime is 2x. That is GS, which stands for the general slope. Now I'm finding the specific slope, which I called SS. And all you do is you plug this number, 1.24, back into 2x. So 2 times 1.24. And if I keep going, let me extend this line for you. This is going to be 2.48. Now that we have the slope and we have this point xy, and let's write it down for you. XY, which is basically 1.24 and 2.5376. This goes back to grade 9 math. So again, you're given the slope, you're given the point, let's solve for b. Y equals to mx plus b. y is going to be 2.5376, which equals to 2.48 times 1.24 plus b. How do we solve for b? You got this. You take 2.5376. You're going to subtract 2.48 times 1.24. And of course, you can do all this in one step with your calculator. So I take my calculator. I take 2.5376 minus 2.48 times 1.24. And that's going to be approximately negative 0.5376. Now again, I am going to round to two decimals. So this is going to be negative 0.54. So this means, therefore, y equals to, if I look at the slope, this is going to be 2.48 times x minus 0.54. Now again, this is really an approximation, so I'm going to put a dot at the top, and I'm going to put a box around this. And again, I'm not going to rewrite this in standard form, but if you want to, you can bring it to one side and make sure A, B, C are numbers such that there are no decimals, no fractions, and the leading coefficient, again, it's positive. Now, at this moment, for you to understand this, I would like you to try the second case yourself. Press pause, go through the same steps. You can look at the left-hand side as a template. When you press play again, I'll be here. Welcome back, everybody. One more time. Y equal to x squared plus 1. My goal is to find the corresponding y value, given that x is going to be negative 3.24. So I'm going to plug it back in. I'm going to take my calculator. I'm going to work it out. So again, negative 3.24, square this, plus 1. In the display, I see the following number, 11.4976. And again, remember, the general slope, y prime, is going to be 2x. So to find the specific slope, which is n by the way, I take y prime of, not 11, that's wrong, y prime of negative 3.24. So I plug the x value back in here to find the specific slope, which means I take 2 times negative 3.24. Again, here comes a little bit of mental math. That's negative 6.48. I'll put a box around this. And again, the fact that we have the slope and we have the coordinates x, y, which is approximately, I'm going to round this like I did from before. We had negative 3.24. And the y value was 11.4976. If I put a box around this, we can solve for b. So again, notice how systematic this is relative to the first column. I'm keeping it as consistent as possible. We're trying to build structure here. So if you solve for b, you plug in y, that's going to be 11.4976, which equals to negative 6.48. I'm going to multiply this. Let's move this to the right. I'm going to multiply this by negative 3.24 plus b. To solve for b, again, I take 11.4976. I'm going to subtract this time, because when you're multiplying two negative numbers, that becomes a positive number, which I'm going to bring to the other side. So I'm going to take this, multiply by 3.24. Again, take your calculator. I'm taking mine. Here we go. 11.49 or 4976 minus 6.48 times 3.24. So again, in the display, it's approximately negative 9.4976. If I round this to 2 decimal places, we're looking at negative 9.50. So this means, therefore, y equals to negative 6.48 x minus 9.50. Now, let's go back to the graph. Do we understand this? How do we double check this? Let me over deliver and go back and graph this for you so you have a dual mindset, right? How do you solve this algebraically? How do you understand this graphically? Do they match? So if I go back, notice this graph that we had in the beginning. So I'm going to zoom in for you now. So we can tell from what we did that the equation of this first line is going to be y equal to, if I round this a little bit more, let's say I round it to 1 decimal now just to give a variety. I don't know what rounding system you're using. This is the 2.5x minus 0.5 case. And of course, the second line is going to be y equal to, if I round to one decimal again, negative 6.5x minus 9.5. And if I have to go back and locate the point, this first point, x, y, is basically approximately 1.2. And the corresponding y value we found to be 2.5. Last but not least, one more point. This point here, we found x to be negative 3.2. The corresponding y value, approximately 11.5. So you can tell that point's out of scale. I hope this makes sense.